Hi, boys and girls. It's Mr. Yates and Miss Garcia again. We, in this video, are going to be going over the answers to the spiral math for Monday, April 20th. So what I'm going to do is I've got my pen or my pencil and my paper right here. And before I get started, I want to remind myself to put down my answers on one side and my work on the other. And even though you're doing this at home, it's good to number them so that way when you're checking your work, you'll be able to know which problems are which when you're coming back with us and checking them. So we'll start with number one right now. Ms. Garcia is going to be starting off with question number one.
Alrighty, so number one says multiplying, and they're having us multiply 2/7 times 8. So you guys are more than welcome to write your number sentence as 2/7 times 8, or you can say the product is, whichever one you guys prefer. So to solve this one, we always want to remember that when we're multiplying a fraction by a whole number, that we always want to make our whole number as our numerator and then write it over 1. So you're going to want 2/7 times 8 over 1. And then once you do that, you are going to be multiplying across. So you're going to have your 2/7 times 8 over 1, and 2 times 8 gives you 16, and 7 times 1 gives you 7. But boys and girls, don't stop there because this is not in simplest form. You want to go ahead and divide it out. And so you're going to do 16 divided by your 7. And so 7 doesn't go into 1, but it does go into 16 twice. And then 2 times 7 gives you 14. And then 16 minus 14 gives you 2. So then you should get 2 and 2/7. And then make sure that that brand new mixed number is in simplest form. And it is because 2/7 cannot be simplified anymore. So your final answer should be 2/7 times 8 equals 2 and 2/7.
Great. All right, so boys and girls, we're going to go on to number two this time. This one, basically we're going to choose the problem that represents the expression right here, which is 1/2 divided by 3, and the correct explanation. So the best idea is for me to first, I'll put, starting with an answer sense, the correct explanation is, I'll leave that blank for now. Now what I'm going to do is before I read all these, I'm going to set up a model just so I know what I'm going to be looking for. So I want to show a model that shows what is 1/2 divided by 3. So I'm not going to label the model yet because I don't know what I'm actually going to be labeling it, but I am going to be able to show a unit bar to represent what's happening. I look at that 1/2 and I know that that is my part that I'm going to be dividing. So I first want to draw a model. I want to take my unit bar, and then what I want to do is draw into 1/2. This part here I'm not going to worry about. I'm looking right here at this 1/2. So it's 1/2 of something, and then we're going to divide it into 3 parts. And I didn't really do a good job of being very equal with my 3 parts, but you really want to try your best to show that these are equal size, equal value. Each one of these is 1/3. Or sorry, not 1/3, but 3 parts. So we have 3 parts here. I'm taking 1/2 and I'm dividing it into 3 parts. My quotient will be 1/2 divided by 3 is going to equal 1 of these parts. The question mark is, what fraction of the whole unit bar is that question mark? So what fraction of the whole unit bar would it be? Now I can look through here and I can draw the additional 3 here. So I'm always doing the same on this side as I do here, so that I show that the 3 parts of 1/2, one of those parts is a fraction of the entire unit bar. So I look right here and I say 1/2 divided by 3 is going to equal 1 part, which was 1 out of 1, 2, 3, 4, 5, 6. So it's 1/6. So 1/2 divided into 3 parts is 1/6. So knowing that, now I can go look at my explanations and see which one makes the most sense. Let's look at A. Karen had a half of an hour to complete her 3 chores for the evening. What fraction of an hour can Karen spend on each chore? Karen can spend 1/4 of an hour on each chore. Well, you know, over here, boys and girls, I look at that on the left and I realize though that what I figured out was that 1/2 divided by 3 equals 1/6. So I know right now that the first answer is not going to work for me. So I'm going to move on and try that again. Let's take a look at the next part here. All right. I was trying to erase out of there, but I can't. So I'll just go on and move on. All right. Well, let's take a look at B. Karen had half of an hour to complete. Oh, I'm trying to erase that last little bit. Karen had half of an hour to complete her 3 chores for the evening. She has 3 chores. Okay, there's half of an hour. What fraction of an hour can Karen spend on each chore? Well, Karen spent 1/7 of an hour. That doesn't make any sense because, again, I know that 1/2 divided by 3 is going to equal 1/6. So B is not going to work. A is not going to work. Karen had half of an hour to complete her 3 chores for the evening. What fraction of an hour can Karen spend on each chore? She can spend 1/6 of an hour. Well, we are taking 1/2 of an hour and dividing it into 3 parts. That makes sense right here. Oops. However, 1/6 of an hour is the quotient for each chore, and that's what I get here for my dividend. So that seems to make the most sense right now. That actually seems like it is the best answer here. And I'm looking down at D, and yeah, 1/2 of an hour, 3 chores, but it says here 1/5 of an hour, so I know that this one is not going to be correct. And I should have circled it, but I'll just cross it out. So boys and girls, C is going to be the correct answer on this one. If you said C, I would kind of give you a break on this one because it's a lot to write. Or you should say Karen had half of an hour to complete her 3 chores for the evening. What fraction of an hour can Karen spend on each chore? Karen can spend 1/6 of an hour on each chore. So either you wrote out C, and I usually would put that in there to say that. I'm surprised I didn't for this one. Or if you did all the work on this one and wrote it all out, good for you. That's really a good way to do that too, boys and girls. That way you know. So either one's going to work. Key thing here is that you're choosing the one that has 1/2 divided by 3 is going to equal 1/6. In the interest of time, we're going to go ahead and move on forward now. And Ms. Garcia, do you want to take a look at number 3?
Yes. And just to double check, that says 15, not 1.5 floors, right?
Let me zoom in on it to doubly make sure. Yep, 15.
Okay. So this one says the Grand Hotel has 15 floors and a total of 1,005 rooms. If each floor has the same number of rooms, how many rooms are on each floor? So boys and girls, you're first going to want to write out your answer sentence. So for your answer sentence, you should have.
And Ms. Garcia, I'm just going to move this really quick down here so everyone can see what you're talking about. All right,
Good.
go ahead.
All right, so for your guys' answer sentence, you guys should write blank rooms are on each floor. Or you can say each floor has blank rooms. That one works too.
What are some of the key words they really need to make sure they have on this one?
You want to make sure that you have the word rooms and then each floor.
Yep.
Because we want to make sure that we're labeling what that number represents, which is going to be rooms. And we want to know where those rooms are going, and they are going to be on each floor. So those are going to be your guys' key words. So for this one, you're going to want to go ahead and divide. But I drew a model for this one.
What's a good idea?
So I drew a unit bar.
All right, let me do that right now. What did you label the unit bar, Ms. Garcia?
I labeled it, well, I forgot to label it. So we're gonna go ahead and label it the Grand Hotel rooms.
Okay. Okay, so I put GH rooms.
Yes. And then, so it says the Grand Hotel has 15 floors and a total of 1,005 rooms. So I put I put 1,005 at the very end of the unit bar because that's the total number of rooms that we have. And then it says that the hotel has 15 floors. So I split that into 15 sections.
Oh, goodness, Miss Garcia, you didn't have to draw, you weren't drawing out all those 15, were you?
No, I just did a first one and a last one, and I put 3 dots in the middle.
Okay, so I'll put first floor here. And I know my last floor is the 15th floor, so I'll just put 15th right there. All right.
And then we want to know how many rooms are going to be on each floor. So we want to know what each section of that unit bar is going to represent. So our expression for this is going to be 1,005 divided by 15 equals question mark. Perfect. So then your next thing, we used the full first sentence. So let's go ahead and take a look at our second sentence. It says, if each floor has the same number of rooms, how many rooms are on each floor? So we have our expression. So let's go ahead and solve it out. So when you divide 1,005 by 15, "15 can't go into 1, and it can't go into 10, but it can go into 100, and I put it when it goes in 6 times. And then 6 times 15 is going to give you 90. And then when you subtract that 90 from 100, you get 10. Then you drop down your 5, and then it goes in 7 times, and it gives you exactly 105. So you guys should have ended up with 67. So, and your answer sentence should read, 67 rooms are on each floor.
Great. I'm going to go over to the back. I'll do my answer and my work. Number 4. And I'm going to scroll on down. I'm going to give a shout out, and I forgot that I think Mark and I think it was Ethan notified me today that Mr. Yates, you left out 4 and 5. And I said yes, and that's a bonus for you guys because you don't have to do them today. So we're going to skip right on down to 6. And we'll go from there. So Emily drinks 6 cups of water every day, while Jackie drinks 8 cups of water every day. Which graph represents the total amount of water consumed by Emily and Jackie over a 4-day period? You can just write graph A, B, or C, or D in your answer sentence. You don't have to draw the graph. And yeah, I'm not going to ask you to redraw this whole graph, but let's take a look at them and see which one shows Jackie's drinking of the water and Emily's drinking of the water. So it says Emily drinks 6 cups of water every day, and Jackie drinks 8 cups of water every day. So what we should basically start with is first to see, all right, this one, oh, let me look, because it should be like 6 and 8. Let me look at this a little bit more here to zoom in on it. I don't see, this is day 1. Emily and Jackie, well, Emily's not starting off at 6, and that's where it should be. It looks like it's starting off at 8, so I don't think this one makes the most sense yet. Yeah, it's like, that doesn't make sense. Let's go take a look at letter B. Now on this one, Emily is drinking, looks like less than 4 cups of water, and Jackie's drinking 5 cups, and that doesn't fit either one of these, 8 or 6. So I'm going to go on down. And I'm going to look at C. And again, I'm looking right here. Jackie's drinking, looks like 10 or 11 cups of water, and Emily's drinking, looks more like 5 cups of water. That doesn't quite make sense either. That's not fitting what we're seeing. So let's go ahead and move on. Well, this one, Emily's right about where she's supposed to be, 6 cups of water to day 1. And then Jackie's drinking 8 cups of water on day 1, so that makes sense. So Jackie should be going 8 on the first day, 16 on the second, 3 is 24, and then, yeah, 4 is 32, because 8 times 1, 8 times 2, 8 times 3, 8 times 4. So that makes sense. Emily is 6 times 1, and let's see what else we got here. Yep, 6 times 2, 6 times 3 is 18, and 6 times 4 is 24. So by default, and also by checking them, so I make sure, looks like D is the correct graph. So I'll put that here. And I would like you to, you don't have to write the graph, but I would like you to write that, you could say the correct graph. If you really wanted, you could say that it represents the total amount of water consumed. Either one is okay. You could say the correct graph that represents. The keywords here are going to be correct graph. I'm just going to add this extra detail. Represents the total water consumed is D. All right, great. Let's move on to number 7 now. And I'll zoom up here. Oh, yeah, there we go. All right, Ms. Garcia.
Okay, so number 7 is going to be having us,
It just went a little cray-cray on me there.
I believe it was
Hold
like
on,
45 pounds or something like that.
Yeah,
There.
it's back up there now.
Okay, so it says complete, and they want us to figure out how many ounces, 45 ounces, are equivalent to how many pounds and ounces. So on this one, they're kind of telling you, like, hint, hint, you're going to have a remainder. So you guys should have looked at like some sort of conversion chart. But so there are 16 ounces in 1 pound. So you're going to want to remember that when you're going from a small unit of measurement to a big unit of measurement, you're going to be dividing, because remember, I think it's shingles buys donuts or shingles
Shakes.
Oh, shakes, dang it. Sorry, Ethan.
Ethan's going to email us. You know, he's going to be like, Mr. Yates, you said it again.
Okay, Ethan, just for you. Shakes buys donuts. So you're going to want to go ahead and divide your 45 ounces by your 16, because 16 ounces are in 1 pound. So when you guys divide that out, and make sure to turn your guys' paper, because we don't need those cars crashing on the highway. So 16 can't go into 4, but it can go into 45, and it goes in twice. And then 2 times 16 gives you 32, and then when you subtract, you should end up with 13. So your guys' final answer should read 45 ounces equals 2 pounds and 13 ounces. Because your 2 is going to be your pounds, and your 13, which is your remainder, is going to be your ounces.
All right, great. And we're going to move on now to number 8. What is the value of each expression? Write in simplest form. What I'll do is I'll write out the number sentence here, 1/9 plus 1/6. And I do have to remind everybody, we're not going to be adding these denominators together. In fact, we can't until the denominators are the same. And one way I could do that is I could get their, there's a lot of different ways to change it over. I think what I'll do is I'll look for that least common multiple or greatest common factor. I think least common multiple here is going to be the best way to do this. What I can do is I know that I can multiply 6 times 3 and get 18. and I can multiply 9 times 2 and also equal 18. So now I have I have the least common multiple of 9 and 6, and that's also going to be my least common denominator for both these fractions. I also want to make sure that I multiply 6 times 3 down here on the bottom, so I'm going to multiply on the top. 1 times 3 is 3. Over here, I'm going to take 9 times 2 and equal 18, and whatever I do on the bottom, I'll do on the top, so it's 1 times 2 equals 2. Now I'm able to add because my denominators are the same. 2 plus 3 is 5, and I'm going to be getting 5 over 18. One thing I like about doing it this way, where I find the least common multiple, is that I won't have to simplify when I'm done adding. I automatically know that when I find the least common denominator here, when I add these up, I won't have to simplify the fraction down. And 5/18 I can't simplify. So now I know that 1/9 plus 1/6 is equal to 5/18. Boys and girls, make sure that when you're done, as always, click on the survey link that's right below this assignment and make sure that you fill out the survey. Some of you are doing the work, but you're not letting us know that you're doing it. And so we want to know so you get credit for it. So make sure you fill out that survey before you move on. Thanks, boys and girls, and email us if you have any questions. Bye-bye.